hierarchical clustering example. Let's understand hierarchical clustering through an example. In the given example, hierarchical clustering is used to find the distances between the different cities in kilometers. The following matrix traces a hierarchical clustering of distances in miles between different cities. The method of clustering is single link. Here, as you can see from the given distance matrix, the nearest pair of objects is TO and MI. MI and TO are merged into a single cluster called MI-TO. As MI column has lower values than TO column, MI-TO consists of MI column values. MI-TO column has one index with 0 value. This is because there is no distance between cluster MI-TO and MI-TO. To get a new distance matrix, we compute the distance from this new cluster to all other clusters. Now the nearest pair of objects is NA and RM. These are combined into a single cluster called NA-RM. To get a new distance matrix, we compute the distance from this new cluster to all other clusters. In the similar way, the nearest pair of objects is BA and NA-RM. These are combined into a single cluster called BA, NA-RM. To get a new distance matrix, we compute the distance from the new cluster to all other clusters. Similarly, now the nearest pair of objects is BA, NA-RM, and FI. These combined into a single cluster called BA, NA-RM, FI. To get a new distance matrix, we compute the distance from this new cluster to all other clusters. Finally, we merge the last two clusters. This process is summarized by the clustering diagram on the right and the final distance matrix on the left. Demo clustering animals. Problem scenario. Consider the dataset zoo.data and look at the information provided in the first 5 rows. The first column denotes the animal name and the last one specifies the high-level class for the corresponding animal. You are supposed to find a solution to the following questions. 1. Identify the unique number of high-level classes. 2. Perform agglomerative clustering using the 16 intermediate features. 3. Compute the mean squared error by comparing the actual high-level class and the predicted high-level class. In a nutshell, you just have to perform agglomerative clustering with the appropriate MSE value. Let's import the required libraries and the data set. Since we have now loaded the dataset, we will extract some basic information from it as our first step. With the info command, it is clear that the dataset has 18 columns in total and 101 entries. Also, there are no null values. Let us now proceed towards the first question, which is extracting the unique number of high-level classes. Most probably, the unique function from NumPy will help. We can plot the unique number of labels obtained using the matplotlib library. Create a figure and a set of subplots. From the plot, it can be seen that we have 7 unique class labels. Now, since we are about to group animals based on their features, it's clear and quite predictive that clustering should be performed. Let's now extract the features, leaving the labels column, and store them in another data frame, say features. Import the necessary modules for performing clustering. Specify the number of clusters as 7. Note that here we are specifying the total number of clusters as 7 because there are 7 unique class labels. Also specify the linkage method as average and the similarity method as cosine. Fit the agglomerative clustering model over the feature variable defined earlier. Let us extract the labels predicted by our model against the features. We can see that we have predicted labels against all of our 101 animals. Although we have 7 labels, but it is numbered as 6, so in this case, we can subtract 1 from our original label column such that it matches the predicted numbers. Now let us move ahead and predict the accuracy of our model considering the predicting parameter as mean squared error. Now evaluate the absolute error by applying square root operation on the mean squared error. Print the resultant error. The root mean squared error we got is 2.43 approximately, which is quite acceptable. Now that we have clustered the animals, let's quickly recap the steps we have covered. Import libraries and the data set. Check for missing values. Identify unique labels and plot them. Extract features necessary for clustering within a single variable. Fit a agglomerative clustering model on the feature data. Predict labels for each animal. Print the RMSE of the model. K-means clustering. Let's look at the steps involved in K-means clustering. K-means is an iterative clustering algorithm whose goal is to find local maxima in each iteration. This algorithm works in these 4 steps. Specify the desired number of clusters K, randomly assign each data point to a cluster, compute cluster centroids, reassign each point to the closest cluster centroid, and recompute cluster centroids in order to check if the convergence criterion is met. Consider the dots given in the diagram as the data points. First, K-means randomly chooses K examples, data points from the data set, the 3 colored points, as initial centroids. This is because it does not know yet where the center of each cluster is. A centroid is the center of a cluster. Assign data points to the nearest centroid. Then all the data points that are the nearest to a centroid will create a cluster. As you can see, there are 3 centroids as red, blue, and purple, and all the data points of the same color is 1 cluster. So in total, we have 3 clusters now. Now we have new clusters that need centers. A centroid's new value is going to be the mean of all the examples in a cluster. Centers are moving because a centroid will have the value of the mean of all the data points in a cluster. We'll keep repeating steps 2 and 3 until the K-means algorithm is converged, that is, until the centroids stop moving.